Homework 9, Compound Interest, Video 2. In the previous video, we introduced the concept of compound interest in contrast to simple interest. Simple interest basically says, put your money down and stare at it, and at the end, we'll calculate your interest and give it to you. Whereas compound interest says, put your money down, and before we get to the end, we'll stop, calculate a little bit of interest and add it on your money, and then continue investing and stop and calculate more interest and add it on. Basically, your pile of money gets progressively bigger, and so every time it earns interest, it earns more because the stack is a little bigger than it used to be. Whereas simple interest says, put your money down and stare at it. It's not doing anything. Now that we're done, we'll put some money on it. But there's got to be a better way to find compound interest besides stopping, calculating simple interest, adding it on, and resuming, and doing that over and over. And there is. There's a formula for compound interest, and here it is. If capital P is your principal, how much money you're investing, little r is your annual interest rate, which will always be given to you as a percent, but should always be converted to a decimal. T is the time in years, so if it's given to you in a different unit of measurement, you have to convert. If it's given in months, divide by 12. If it's given in days, we'll divide by 365. No banker's rule here. But we have a new variable, n. It's the number of times per year interest is compounded. For example, in the previous video, we got interest after every 3 months. So within a year, that means we got interest 4 times. Then the future value is, and here comes the formula, the variable a is still representing future value. It starts out like the simple interest formula with the p, but then it changes. After the p is an open parentheses, and inside the parentheses is 1 plus a fraction. On the top of the fraction is lowercase r, your interest rate. On the bottom of the fraction is lowercase n, the number of times per year that you're going to receive interest. That closes the parentheses. Outside the parentheses is an exponent. Now, in the book, they don't put parentheses around the exponent. I do, just as a reminder on how to put it in a calculator. The exponent is a multiplication problem. It's lowercase n, the number of times per year interest is compounded, times t, the number of years that you're investing. Make sure this open parentheses looks a little more parenthetical and not like an L. Now be careful because this formula doesn't calculate interest, it actually gets right to future value. So let's calculate the problem that we did previously and see if we get the same answer. We should, at least to the near, within a cent because of rounding issues. So let's invest $10,000 at 6% interest, compounded quarterly. The word compounded is the dead giveaway that this is the formula you are using. If you do not see the word compounded, do not use the formula for compound interest. Compounded quarterly for 1 year. We're going to answer 2 questions. What's the future value and what's the interest earned? Now for the future value, we just have to use our formula. But in order to use our formula, we need to know what P, R, N, and T equal. So let's just write those down real quick. Our principal is $10,000, that's what we're starting with. Our interest rate is still 6%, so 0.06. Our time is 1 year, so T is equal to 1. But what will N equal? Remember, N is asking the question, how many times per year is interest compounded? And you can almost always find it in the word that follows compounded. In this case, quarterly. If something happens quarterly, that means it happens 4 times per year. So our N is going to be 4 because of the word quarterly. In future examples, we'll see different adverbs that indicate different values for N. But just to tell you what some of them are, if this said annually, that's 1 time per year, N is equal to 1. If it said semi-annually, that's 2 times per year, N is equal to 2. If it said monthly, that's 12 times per year, N is equal to 12. And in this case, if it says daily, that would be 365 times per year. N is equal to 365. But I digress. We have all the values we need, so let's put them into our formula. Our future value is 10,000 times, open parentheses, 1 plus, and by the way, this 1 plus is just part of the formula. R, which is 0.06, divided by n, which was 4, close the parentheses, and then the exponent, n, which is 4, times t, which is 1. Now, how do you put this in a calculator? Well, you can do part of it individually. You might even know the answers to pieces of this. For example, I know the answer to 4 times 1, so do you. But even if you did know the answer to part of this problem, I'm going to show you how to type the whole thing in your calculator so that you don't have to type this, write something down, type this, write something down. Just do it all at once. Now, how do you put this in a calculator? Actually, it's the same regardless if you have a graphing calculator or a non-graphing calculator, as long as your calculator has an exponent button. And your exponent button will probably look like one of two things. Your exponent button will either look like x to the y power. Whoa, where'd this marker come from? Y to the x power. Or if you have a TI calculator, it looks like that. So you need a calculator with an exponent button. So how would you put this in a calculator? Pretty much exactly like you see it, especially since I wrote these parentheses up here. 10,000 times, open parentheses, 1 plus 0.06. A fraction is just a division problem, so divided by 4, close the parentheses, press your exponent button. I'm going to use this symbol for exponent, although you are responsible for knowing which button on your calculator is the exponent button. If you're not sure, send me a picture of your calculator and I'll tell you which one it is. Once you press the exponent button, now it's time to type in the exponent. And here's why the parentheses are necessary. If I didn't write them and just put 4 times 1, the order of operations will say that the 4 and only the 4 is in the exponent. This is an afterthought. In order to force this 1 to also be in the exponent, you have to trump the order of operations with parentheses. So I will always write this formula, or at least try to always write this formula with parentheses around the exponent as a reminder that you need to type the parentheses when you put it in your calculator. But if you put it all in your calculator correctly, we should get an answer that's pretty close to the one we just got. 10,000 times, open parentheses, 1 plus 0.06 divided by 4, close parentheses, exponent button, open parentheses, 4 times 1, close parentheses, and I should also mention that you have to finish it all by pressing equals, or if you have a graphing calculator, pressing enter. And what did we get? We got that the future value was $10,613.64. I believe in the previous example we got 63 cents. We can attribute that to internal rounding between the beginning and the end of the problem in the previous video. But it's the same answer that we got before with one sequence of keystrokes in the calculator. Now, we haven't answered both parts of the question yet. This is just the future value. How do you calculate the interest? Well, interest is just how much more you have now than you did before. So it's just the future value A minus the principal, P. So we just have to take what we have now minus what we started with. Well, that's easy. $10,613.64 minus $10,000 is $613.64. So keep in mind that the compound interest formula is a formula for future value. The simple interest formula is a formula for interest. If you know future value, but you want to know interest, just subtract your principal.